Welcome to the solution to the problem of the day, which was posted yesterday, 8/3/2026. Okay, the first part was calculate the wedge product of these two vectors. Okay, so we got vector A and B, and we write it like this. A wedge B this is A wedge B. Now remember, there's only two rules, and one of the rules was any vector wedged with itself is equal to 0. So when we FOIL these two things, normally we get four terms. We're only going to get two terms because EX wedge EX is 0. EY wedge EY is equal to 0. So we only get this. 4 times 4 is EX wedge EY. And 1 times 1 is EY wedge EX. Now the other rule was EX wedge EY is equal to the negative of EY wedge EX. So when I flip these, I pick up a negative right there, right? So I get 16. Oh, I haven't flipped them yet. I'm sorry. 16 plus 1. I flip these. I get a negative 1, right? See, this is the same as that. So it's only 15 EX wedge E1. Wedge EY. EX wedge EY. Okay, so this is actually the area of that parallelogram. Let's go look at it. Okay, here's vector A, and here is vector B. And I'm going to wedge A1. Remember, it's important in these wedge products which direction you go. It's real important. So I'm going to wedge A, wedge B. So I'm going counterclockwise. So that's going to be a positively oriented plane. And my claim is the area of this is 15 because we saw from the basis vectors, right? I'm missing there he is, that this was a unit bivector. So it's just area equal to 1. So I'm claiming there's 15 of these unit bivectors inside this parallelogram. Okay? The next part was using both the component form and the geometric form of the dot product, show that the area of the parallelogram found from the wedge product is equal to the area using the old school base times height of vectors A and B. Okay, so the component form, which you know very well, is 4 times 1 plus 1 times 4, so it's just 8. So A dot B equal 8. The geometric form, which you also know, A dot B is equal to the magnitude of A times the magnitude of B times the cosine of the angle between them. All right, so here's the two vectors. So what is the magnitude of A? Well, it's 4 squared plus 1 squared is square root of 6, the 17, and B is exactly the same, right? 1 squared plus 4 squared. And we know the product, so we know everything here. We're going to solve for the angle. We get that, take the inverse cosine, we get 61.9 degrees. Okay, well, what's that going to do for us? Well, it's going to do this for us, right? Now that I know this angle here, this is the angle between A and B, I just drop a perpendicular here. I don't even know where I don't even care where it lands. I just say it's a perpendicular. So what is the sine of this angle? The sine of this angle is the opposite over the hypotenuse. What's the hypotenuse? That's the magnitude of vector B, right? So the sine of this angle is equal to this height divided by the magnitude of B. So we solve for H, and we get 3.63. Now, the area is base times the height. Well, we know the base, that's this. That's the magnitude of A. That's square root of 17 times the height now, 3.63. This is approximately equal to 15. You know, these are irrational numbers, so it's like 14.99999. Okay, wasn't that fun? See you later.